Hi everyone. In this video we'll talk about a new value called the margin of error. The margin of error is similar to another value we've already talked about called the standard error. The standard error and the margin of error actually have the same purpose. Their purpose is to get an idea of how accurate a random sample is likely to be. Since the standard error and the margin of error both have that same purpose, they're both called measures of accuracy. Even though the standard error and the margin of error have the same purpose, they're calculated differently and they're also interpreted differently. I think the difference between the standard error and the margin of error will make sense by the time we get to the end of this video. In this video, we'll go through an example of calculating the margin of error. We'll go through a step-by-step example, but before we do that, we'll go over the definition of the margin of error, and we'll also go through a few diagrams just so you get an idea of what the margin of error means. So let's start with the definition. The margin of error is the distance from the population parameter being estimated to the lower and upper boundaries of an area in which the sample statistic has a certain probability of falling. And I know this definition probably sounds wordy and it's probably not quite clear yet, but I think it'll make sense once we look over a few diagrams of the concept. Let's start with this diagram right here. In this diagram, we're imagining that this point right here is a certain population parameter or population statistic that we want to estimate. It could be the mean of a certain population, or it could be the percentage of something in a certain population. This point right here is just some population statistic that we want to estimate. To estimate this unknown population statistic, we're going to take a random sample from the population, we're going to collect data from the sample, and then we're going to calculate a sample statistic to estimate the population parameter. When we calculate our sample statistic to estimate the population parameter, our sample statistic is going to fall somewhere along this number line. It probably won't be exactly equal to the population parameter because hardly any sample statistic is perfectly accurate. But it'll fall somewhere along this number line, along this range of possibilities. It's going to be more likely to fall somewhere around the population parameter, and it's going to be less likely to fall way down here or way out here because random samples are usually fairly accurate and they're extreme less often. They can turn out to be extreme, but it doesn't happen very often. Now, let's look at this red area right here around the population parameter that we're estimating. And let's try to imagine what we think the probability is that the sample statistic will fall in this red area. Let's just try to take a guess. Well, this red area looks pretty narrow, and the sample statistic would have to fall pretty close to the population parameter and be pretty accurate in order to be in this area. So the probability of the sample statistic falling in this red area probably isn't too high. Maybe we could guess that it's 0.60 or a 60% chance. If it's true that there's a 0.60 probability that our sample statistic will fall in this red area, then the distance from the population parameter to each of these two boundaries would be called the 60% margin of error. The distance from the population parameter to the lower boundary and the distance from the population parameter to the upper boundary would both be called the 60% margin of error. And so this is the 60% margin of error, and this is also the 60% margin of error, and these two are the same distance. In other words, the 60% margin of error would be half of this total red area right here. Earlier in the video, I told you that the definition of the margin of error is the distance from the population parameter to the lower boundary and the upper boundary of an area in which the sample statistic has a certain probability of falling. And that's what we see in this diagram right here. We have an area in which the sample statistic has a 0.60 probability of falling, and the distance from the population parameter to the lower and upper boundaries of the area is a margin of error. The reason why this is called the 60% margin of error is because there's a 0.60 probability of the sample statistic falling in the area. If this probability was different, then this percentage would also change, because this number and this number are always the same. It's just one's a decimal and one's a percentage. So if there was a 0.50 probability of the sample statistic falling in this area, then this would be the 50% margin of error. If there was a 0.80 probability of the sample statistic falling in this area, then this would be the 80% margin of error. Like I said, these two numbers always match up with each other. Let's now look at another diagram. In this diagram, let's move the two boundaries out further away from the population parameter so we have a wider red area. And now let's think about what the probability would be of the sample statistic falling in this red area. Well, since this red area is really wide and it covers almost all of the possible numbers that the sample statistic could equal, there's probably a pretty high chance that the sample statistic would fall somewhere in this red area. Let's say that maybe there's a 0.95 probability of the sample statistic falling in this red area. If that's true, then these two distances would be called the 95% margin of error, because, like I said, this number and this number match up with each other. So I hope these two diagrams helped you start to get an idea of what the margin of error represents or what it stands for. Let's now look at a couple other diagrams so we get an idea of how the margin of error is connected with the idea of a sampling distribution, which is something we've been talking about lately. So if we have a population and we take a random sample from the population and we calculate a sample statistic, there's more than one possible sample that could be selected from the population. For example, if we're taking a random sample of 50 people, there's many possible samples of 50 that could be selected. There's many possible combinations of 50 that could be selected. And the actual sample will just be one of those possible samples. The possible samples that could be selected have a distribution called the sampling distribution. The actual sample will be one of the possible samples in the sampling distribution. While we're looking at this diagram, let's mark off a boundary point down here and a boundary point up here. And let's think about the probability of the sample statistic falling in that area. Maybe we can mark off a point right here and a point right here. So let's think about the probability that the sample statistic will fall between these two boundaries. Well, that probability depends on the percentage of possible samples that are in this area between these boundaries. If 70% of the possible samples are in this area, then there's a 0.70 probability of getting a sample from this area. If 80% of the possible samples are in this area, then there's a 0.80 probability of getting a sample from the area. So basically, the probability that the sample will come from this area between these 2 points depends on the percentage of samples that are in this area. Let's maybe take a guess that 70% of the possible samples are between those two boundary points. Well, if 70% of the possible samples, or 70% of the possible combinations, are in this middle area, then there's a 0.70 probability of getting a sample from this middle area, which would mean that this distance and this distance would be the 70% margin of error. Like I said earlier, the 70% margin of error is the distance from the population parameter to the boundaries of the area in which the sample statistic has a 0.70 probability of falling. Now let's look at another diagram. Now let's mark off this point down here and this point up here, and let's say that 95% of the possible samples are between these two boundaries. Well, if that's the case, then there's a 0.95 probability of getting a sample between these two boundaries, and the two distances would be the 95% margin of error. In this diagram, I'm just helping you get an idea of where the probability comes from. The probability that the sample statistic will fall in a certain area depends on the percentage of possible samples that are inside that area. So let's now move on to how the margin of error is actually calculated. So these are the steps to calculate the margin of error. First, you have to select confidence level. The confidence level is the probability that the sample statistic falls between the lower and upper boundaries. The confidence level is just the probability that we've been talking about. It's the probability that the sample statistic will fall between the lower and upper boundaries. So the first step in calculating the margin of error is actually picking what you want the confidence level to be. If I decide that I want the confidence level to be 0.70, then what that means is that I'm going to be calculating the distance to the boundaries of the area that has a 0.70 probability. And I'm going to get the 70% margin of error as my answer. If I decide that I want the confidence level to be 0.90, then what that means is that my goal is to calculate the distance to the lower and upper boundaries of the area that has a 0.90 probability. And I'm going to end up getting the 90% margin of error as my answer. So when you're selecting the confidence level, you're really just selecting which margin of error you want to calculate. You're deciding if you want to calculate the 60%, 70%, or maybe 80% margin of error. There's when you're taking a sample from a population, there's a different margin of error for every percentage between 0 and 100, and any of them could be calculated. And it's actually up to you to decide which one you want to calculate. Once you've picked your confidence level, and you know which margin of error you want to calculate, then the next step is actually calculating the margin of error using a formula. The next step is using the margin of error formula to get the margin of error that you want to calculate. And the margin of error is calculated by multiplying a value called the confidence coefficient by the standard error. which is a value we've already been talking about already. So the formula for margin of error is just confidence coefficient times standard error. And the confidence coefficient actually isn't calculated with the formula. Instead, a person just looks it up in a table. A person who wants to calculate the margin of error can go to a table and just look up the confidence coefficient to plug into the formula. The standard error over here has to be calculated with a formula based on the data. So when you calculate the margin of error, you look up the confidence coefficient in the table, you calculate the standard error with a formula, and then you multiply the confidence coefficient by the standard error. Now let's talk about how you actually look up the confidence coefficient in a table. There's the table that allows you to look up the confidence coefficient that you need for your selected confidence level. And the table has several rows. Each row is a different confidence level. And when you go to the table, you go to the row for your confidence level, and then you go over here to get your confidence coefficient that you need. If I want to calculate the 70% margin of error, I would just go over here and get this confidence coefficient and plug that into the formula. If I wanted to calculate the 80% margin of error, I would go over here and get my confidence coefficient and plug that into the formula, and so on. So the confidence coefficient that you pick from the table actually determines which margin of error you will calculate. If you pick the confidence coefficient for 95% confidence level and plug that into the formula, you'll get the 95% margin of error. If you take the confidence coefficient for 99% and plug that into the formula, you'll get the 99% margin of error. Like I said, the confidence coefficient that you pick from the table determines which margin of error you will calculate. So now let's actually go through a few examples of calculating the margin of error. I said right here that we would look at how to calculate the margin of error for a sample mean and for a sample proportion, which are two different statistics, but actually in this video we'll just look at an example of the margin of error for a sample mean. We won't look at an example for a sample proportion in this video. So before we calculate the margin of error for a sample mean, let's look at the formula that we're going to need to use. We're going to need this confidence coefficient right here, which is with the letter Z stands for it, with this subscript right here. The subscript is actually alpha divided by 2. Don't worry about the subscript, it's just a notation. And this right here is the standard error that we looked at in an earlier video. We talked about how when you're sampling from a large population, you can use a short version of the standard error formula, which just has the population standard deviation sigma and the sample size n. That other part is left off. And when you calculate the margin of error, there's actually always some requirements that you have to follow, or some rules you have to follow in order to be able to calculate the margin of error correctly. If you don't follow those rules, then the formula will actually give you an incorrect answer. When you calculate the margin of error for a sample mean, the rules that you have to follow are you need to be taking a random sample, and also either the population that you're sampling from has to have a normal distribution, or your sample size has to be at least 30. let's talk about the reasons for these rules. Um, you have to be taking a random sample, because if you're not taking a random sample, if you're taking a non-random sample, there's no way to actually predict how much error you will make, because it all depends on how biased the sampling process is. The amount of error that you're likely to make is only predictable if you're taking a random sample. That's because when you take a random sample, the sample statistic is likely to be at least fairly accurate, and extreme samples are less likely. The reason for this other rule right here is because in order to calculate the margin of error for a sample mean, the possible samples that make up the sampling distribution have to have a normal curve, or a normal distribution. And the sampling distribution is normal if one of these two things is true. So now let's look at this example right here. Let's go through an example of calculating the margin of error. Let's look at this scenario. A person wants to estimate the mean height of a certain city. The person knows that the population standard deviation is 2.3 inches. In other words, the person knows that the standard deviation of all heights in the city is 2.3. But the person doesn't know the shape of the population. The person doesn't know if the heights in the population are skewed, or bell-shaped, or some other type of shape. The person takes a random sample of 40 people, records their 40 heights, and then calculates the mean of the height of the sample. The person calculates the sample mean by adding the 40 heights and dividing by 40. And let's think about, in this situation, can a margin of error be calculated to get an idea of how accurate the sample mean is likely to be? Well, we have to check our rules and see if they're followed. We have a random sample. The question says it's a random sample. And we don't know whether the population has a normal distribution, but we do know that the sample size is 30 or larger, because 40 is 30 or larger. So we can check off both requirements, and the answer is yes, we can calculate the margin of error for whichever percentage we want, or whatever confidence level we want. Let's say we want to set the confidence level to 95% and calculate the 95% margin of error. Well, the first step to do that would be to look up our confidence coefficient. We would go to our table and go to 95%, and then get our confidence coefficient. This table is actually online. You can look it up if you want to. I might send it out through email, but in this video I just decided to create my own version of the table and put it on the slide. So the confidence coefficient for 95% is 1.96. That's the number we'll need. The next step is to actually use the formula to get the margin of error. So our confidence coefficient is 1.96. Our population standard deviation is 2.3. That was known to be true in the question. And our sample size is 40. And if we go through all of this math, our answer would be 0.71. I didn't show all of the steps because I ran out of space, but if you wanted to work this out on paper, you would need to start with finding the square root of 40. Once you do that, you would just divide 2.3 by the number, and then after that you would multiply 1.96 by this number and get your answer. It would take about 3 steps. So our answer is 0.71. In this situation, the 95% margin of error is 0.71. Now let's look at a diagram to help us understand what this answer actually means. let's so that we know what it's telling us. So in this situation, we're taking a random sample of 40 people from the population. The mean height of the city is unknown because that's what we're trying to estimate. But the standard deviation is known to be 2.3. The heights of the sample are recorded, and the mean height of the sample is calculated. The mean of the 40 heights is calculated. And here in this diagram, we have the population mean that's being estimated, which is the mean height of the city. We have a lower boundary down here and an upper boundary down here. And this area between the boundaries includes 95% of the possible samples. And there's a 0.95 probability of getting a sample from this area. And we know from our calculations that this distance and this distance are both 0.71. Overall, we know that when this sample is randomly selected from the population and the sample mean is calculated, there's a 0.95 probability of getting a sample mean somewhere within 0.71 of the population mean. In other words, there's a 0.95 probability that the sample mean will end up being somewhere between 0.71 below and 0.71 above the population mean. So that finishes our example of the margin of error. Let's finish this video by just going over a few important points about the margin of error. First, when it comes out to a smaller number, a more accurate result is expected. In other words, when it comes out to a smaller number, less error is expected. So when a person calculates the margin of error, the person uses the size of the margin of error to get an idea of how much error is expected. Also, when it comes out to a smaller number when either the sample size is larger or the population has less dispersion. That's because less error is expected in these two situations. A more accurate result is expected in these two situations. Also, the margin of error can only be calculated for random samples, which is something that we talked about a few minutes ago. That finishes everything for this video. I hope this gives you a good introduction to the idea of the margin of error, and just let me know if you have any questions.